I'm recording that. Excellent. Today we're talking about volume of cylinders and prisms and cylinders and prisms. What do cylinders and prisms have in common?
Well,
They're 3D solids. Yes. What else?
They both have bases.
How many?
two.
They have two bases that are the same, right? In a cylinder, it's a circle and a circle, right? In some sort of other shape, such as a trapezoidal prism, it's a trapezoid and a trapezoid. In a octagonal prism, it's a octagon and an octagon. Okay? So we're going to talk about volume. The reason we're talking about these is because these two are very similar. Cylinders and prisms, they both have the same bases, okay? Tomorrow, we're going to talk about pyramids and cones. Why are pyramids and cones similar? They have one base and they have one vertex point above it. That's why they're similar. So one base, vertex above it. Okay, so today's the easier day. Tomorrow's still fine. It's still okay, don't worry about it. But today, in this lesson, you will learn how to calculate the volume of prisms and cylinders. What do you think goes in this blank? Blank is the measure of the amount of space contained in a solid. Oh, volume. There we go. Volume. Volume. How many 1 centimeter cubes can fit in the right rectangular prism to the right? Why don't you try to estimate this? Get your thoughts together, and I'm going to talk to Ms. Shady, and you guys are going to figure this out for a second. Yes, Ms. Shady.
Sorry for interruption. We have located private unroofed telephone. We have it in office. At your convenience, you can send her down.
That's awesome. Thank you very much.
Thank you.
She's happy.
I don't know.
You guys are calculating how many blocks there are. On your market, don't say it out loud. You're calculating them. You're calculating them. Don't look at me. You're calculating. I'm not the block. Again, you're not saying it out loud. Okay, here's what you might do. You might count, well, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's 12.
No,
There's 12 in this layer right here. This layer right here. There's 12 of them. And how many of those go back?
3.
There's 3 of those layers. So you can say like 12 times 3.
36.
Anybody do this in a different way? Shh, I'm not sure why you're still talking. Yes.
I thought you were counting all of them.
We are counting all of them.
Like on each side.
Yes, all of
Each side.
it was 36.
Sure. What'd you do?
6 times 2.
Yeah, I'm trying to
Alright,
explain to
so what he did is he figured out these, there's 1, 2, 3, 4, 5, 6 on the right side. And then you notice that that takes care of like this block right here. There's 6 of them right there. And he multiplied 6 times 1, 2, 3, 4, 5, 6. So he said 6 times 6 equals 36 blocks. Which I agree with. Yes, ma'am.
Okay. Well, so wouldn't it be 6 times 2, and then 12 times 2, and then 18 times 2?
No.
Why? If you could add all of the blocks together?
Yes.
But what about the other side?
Well, let's go. You said, hold on. We're going to talk about what Nicole just said. You said, what are you going to do here?
Like, are we adding both the faces? Or like the bases?
We're adding up all the blocks total. But what you're doing is you're having some that overlap. So when you did 6 times 2, that takes care of all the front ones,
I
right?
know, but what about the other side?
Okay. So there's 12 on the front. There's also 12 on the back, right?
Yeah.
And there's 12 in between.
Yes.
Yeah. So there's 12 plus 12 plus 12.
That equals 36.
Yeah, but I was also doing the top and bottom.
But weren't the top and the bottom one those also already counted when we counted all the front ones? Because like this block is, that block right there is both a front block as well as the top block.
Okay, never mind.
Oh, yeah. We're talking about number of cubes.
Yeah.
Not number of sides.
At
or
least my
anything
shirt wasn't inside out to be
Okay. Yeah.
Okay. Please, Madison, what do you think? 6 times 3 would be how many are on the top? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So you should have 18 of them. Those are all the ones that are on the tops. There's also 18 on the bottom. So you said 18 times 2 equals 36. Whatever we're doing, we're still getting 36 cubes. That's really bad handwriting. How did you arrive at that answer? Well, look over there. That's how we do it. Okay. So whatever we defined our base as, in this case we defined our base as the front. In this case we defined our base as the right side. In this case we defined the base as the top. Whatever you do, you're doing base times your height. Or in other words, the area of the base times the height is going to equal our volume. So the area of the base times the height. That's what we're doing. Same. Rectangular prism volume conjectures. If B is the area of the base of a right rectangular prism and H is the height of the solid, then the formula is B equals capital B times H. Does it matter that it's capital?
Yes.
Does that make a difference? It does. Okay? So using this, what are we going to define our base as here? The front, back, left, right, top, bottom. What do we want to say? Katie, what do you want to do? The front. So Katie's saying the front. So for us, what is the area of the base? How do we figure that out?
6.
How do you figure it out?
Base times height.
Okay, base times height would be 3 times 2. And what's the height? It's the distance between the front and the back. 4. All we do is we say 3 times 2, which is 6 times 4 is 24. What would our units be?
Centimeters. Square centimeters.
All right. Let's try this one more time. Apparently people aren't paying attention here. I'm going to write this in with the units.
What?
Volume equals base times height. Okay. To find the area of the base, we're going to do 3 centimeters times 2 centimeters times 4 centimeters, right? So I'm going to multiply the numbers. 3 times 2 is 6 times 4 is 24. I agree with that. What's centimeters times centimeters times centimeters? Cube. Whenever we talk about volume, it needs to be 3-dimensional. Volume is 3-dimensional. That's why this is a 3D thing here. It's also, that's why we also talk about little tiny cubes. It's because it's going to be cube. Oh, yes, ma'am. Go. Volume equals area of the base times the height. That means we're going to do 8 times 3 times 12. What's 8 times 3 times 12? 288. So it's 288 cubic centimeters. Next one. Volume equals the area of the base times the height. I always want you writing these equations out. So that'd be 10 times 10 times 30. 10 times 10 is 100. Times 30 is 3000, which is also called 3000. Cubic centimeters. Excellent. Any questions?
Yes, sir.
All right. What's different about this triangular business over here? Yeah, the base is now a triangle. Can we just count the number of cubes? No. A little bit different. We actually find the area of the base, though. I don't know if you can tell this is actually a right triangle. It's kind of weird. This comes out like so, and it looks like this, but it's trying to draw it in 3 dimensions. It is a right triangle where the base of it is 9, the height of it is 12. So we're still going to do this by volume equals area of the base times the height. How's the prism different? Well, the base is a triangle. Find the volume of the triangular prism. Well, it's still just volume equals area of the base times the height. That means we're going to do 1/2 12 times 9. Is that right? 12 times 9 would be the area of the base. 1/2 12 times 9 is the area of the base. How tall is the prism? What's the distance
16.
between the two triangles? 16. So we are doing
What?
1/2, 12 times 9.
So when the I thought it was base times height.
It's the area of the base times the height.
Well then what? Why?
All of this is the area of the triangle, and 16 is the height of the prism.
So was I more the volume? Or no, the half base times? Oh, never mind.
So 1/2 of 12 is 6. 6 times 9 is 54. 54 times 16 is what? 864. And this would be cubic units. So we write units cubed. Does anyone have any questions on this? Any questions? Austin? Question? Dog? Yep. Dog? Dog? Alright, let's talk about this. What shape does the stack of crackers make?
Cylinder.
Oh yeah, it looks kind of like a cylinder, right?
Those crackers look yummy.
It's a stack of crackers. Volume equals base times height, where B is the area of the base and H is the height. Okay. What shape is the base? Circle. That's pretty easy. Find the volume of the cylinder created by the stack of crackers. Okay. Well, we have volume equals the area of the base times the height. What's our radius? Be careful.
1.2 divided by 2. Is that right? Is that one?
So we
Yeah,
have
that's right.
Now we're answering the question.
so area equals pi r squared. 8.6 squared. How tall is our crackers? How many centimeters? 2.5. Hey, one thing I want to point out now, it does come up on your homework. When you do this, you need to make sure that your units are the same, centimeters and centimeters. If this was in like meters, like 3 meters high or 2.5 meters high, like that'd be 12 feet of crackers, that'd be a lot of crackers. You need to convert it into centimeters, or you need to convert the centimeters into meters. Whichever way, I don't care which way it works, but you need to have the same units. Okay? So if you have inches and you have feet, you got to convert one to the other one. They both have to be the same before you can calculate. If you have yards and you have inches, you need to make sure they're the same thing. By the way, this will come up on your homework somewhere. Okay? You need to have the same units. Why don't we calculate this to be 0.36 times that. We're less than 1 times pi. We're sitting somewhere probably like around 2. 2.8. Okay. Let's run it there. That's fine. 2.8. What would our units be? 2.83. Units cubed. Centimeters cubed. That's good. Did you guys get 2.83?
Yeah, totally.
Totally. Sweet. Moving on. Are we on the back side yet? Sweet. Right triangular prism. It does a little something different here. It actually says the height of the prism. It uses a capital H. Some books will do that, some books will not. Okay? So every so often you'll see problems like that. Honestly, you're looking at this, you're looking at the triangle. This is the base of the triangle. This is the height of the triangle. And it makes sense that the capital H represents the height of the prism itself. Not all books will do that, just so you know. Sam, can you move your chair down, please? Again. So, when we're doing this, Austin, formula for volume. Yeah, the area of the base times the height. How do we find the area of our base? One half 6 times 8. Okay. 1/2 8 times 6. And what's the height of the prism? Austin. 20. So I'm just going to do this. 1/2 6 times 8 times 20. 6 times 8 is 48. Half of 20 is 10. So I just think I'm at 480. Is that right? And I don't have any units on here, so I better say cubic units like so. You guys are getting much better at saying cubic units as opposed to units cubed, by the way. Why don't you guys try the next one on your own? There's no numbers. I don't know why. I would like saying the number. Try the next one on your own. Again, please write the formula. Please show all your work. I don't want just random answers. Show all your work. Circle or box your final answer. Is it a square? No. It's not a cube either. It's a rectangular prism. It's actually labeled that right above it. I guess you're curious.
What?
How many people got 504 cubic units?
Not me.
Look at all those hands. Look at all those hands. Look at them all. That's awesome. Okay. Next, we have a cylinder. Awesome. Here we go.
That was cute.
Justin, how do we figure out this awesome cylinder's volume? Volume equals what? Area of the, don't just say base on height, say area based on the height.
Area of the base.
How do you find the area of the base?
5 times 4
What is the base? What shape is the base? Circle? Okay, how do you find the area of a circle? Don't tell him, he's got to figure out himself. What is it? What?
She said it,
I
not
can't
me.
hear you. Okay, so pi r squared. What's our r? 4. So we do 4 squared. What's the height of our cylinder? 10. Okay, so the area of a circle is just pi r squared. The 2 came in yesterday when we were talking about the surface area, and there were 2 circles. See the difference? That's where the 2 came from yesterday. Okay, so 4 squared is 16, so we'd have 16 or 160 pi. Multiply that by 3.14159265497. We're sitting upwards of pretty close to 500, just under 500. Well, like 490 something. What? 526.
That's
6'5". That's 6'5".
I run to 7.
7.
How do you run a 5 up to a 7?
What, you run the 6?
Oh, the 6 is in. Well, the 2 decimal places. We'll do that. Am I done with that? Is that right? That's half a point off, isn't it?
No, that is half.
Half a point.
That's not good, we don't want that.
We gotta get the cubic units in there. Alright, Sierra! What is the name of this shape, geometrically speaking? A right triangular prism. That is genius. Good job. Okay. We have 3, we have 4, we also have 5, there's also 10. There's a lot of numbers on here. What does any of that mean to us? The height of the prism is 10, yes. No. That's the hypotenuse. Base is 4. What's the height of the triangle then? 3. Nope, that's the height of the prism. 3. So we're looking at this triangle. The triangle looks like this. I'm just going to redraw the triangle. It says this is 3, it says this is 4, it says this is 5. If we were just finding the area of this, we just do 1/2 3 times 4, right? That's what it looks like. If you need to redraw whatever the base looks like, that's fine. Because some people will accidentally use 5 somehow and find the area. Well, you don't. If it was drawn like this, you wouldn't. So just don't be mistaken when it was drawn like that. Okay. How do you find the volume here? What's the formula? Say it correctly.
Oh,
No. What is? How do you say this? What's that mean? Area of the base. Times height. Okay. How do you find the area of the base, Sierra? Okay. Times 3, which is the height. And then what's the height of the prism? 10. So we'll multiply that whole thing by 10. Perfect. So 3 times 4 is 12. Half of 12 is 6. 6 times 10 is 60. No calculator needed. And we'll say cubic units, right? That's just math right there. Simple. Down. Moving on, we got some more, right? Oh man, what's that?
Pentagonal prism.
It's a, why would we say right pentagonal prism? Does that make any sense at all?
They're all right angles. Okay.
What's the difference between a right and an oblique?
Oblique.
Yeah, that's right. One is a right angle, 90-degree angle, and one's not. Where are your obliques? Everyone touch their obliques? They're right here. Yeah, these are the muscles right here on the sides of your abs. They're right here. Or they're over here. So if you have really strong obliques, sometimes people will like be doing sort of this exercise, or they'll hold on like giant plates. They'll sort of be doing this exercise. People do this sometimes. They're working out their obliques. The idea is, the reason it's called oblique is because you're leaned over. Okay, that's what the muscle is. It's fully stretched out here, but it's being flexed right here. Okay, this is your oblique. What happens is if you have an oblique prism, it means instead of being straight up and down like a cylinder would be, all of a sudden it's leaning over. Okay, it's kind of like a rectangle versus a parallelogram. So a rectangle is like this, parallelogram is like bang. Okay, just kind of tipped over. And an oblique would just be, those things are still parallel, but instead of being directly over each other, one of them moved over so it kind of slants towards oblique. It's flexed as oblique.
Alrighty then.
What's that?
In class.
If I could draw a cylinder for it, a normal cylinder would look like this, right? And this is a right angle right there. And an oblique one would look like maybe like this, where it's leaning over.
So there's really not a difference? Like, are they both? Are they both?
Well, clearly the difference. One's having a tough day. He's like, I'm falling over. Whoa! That's the difference. And you guys explored that on Friday, so hopefully you guys know the difference in case it comes up. Okay, what's this again? A pentagonal prism. Okay, so what's the base? What shape? It's a pentagon, right? So when you find the volume equals the area of the base times the height. How do you find the area of a base of a regular pentagon? How do you do that? Well, that's going to be 1/2 S times A times N. That's your, how do you find the area of that base? That's it right there. So, 1/2, what's the S stand for? Side. Side, how long is the side? 6. How long is the apothem? 8. What's the number of sides in a pentagon? 5. And what's the height between the two pentagons?
4.
Oh. Look at all those numbers. We got 20 and half of that's 10, so 480 again. Is that right?
Yeah.
What are our units? Cubic meters. You guys are too smart. Too smart. No, you guys are 3 smart. Is that it? Is that all you guys got?
Yeah.
That's it. I don't know why I have more slides, but it says it's only 6 of 10. I have no idea. It's probably yesterday's lesson. Oh yeah, that's good. We don't have to do that. I was like, I don't know what else I'm going to teach here. That's not why I know that we're going to teach here. Okay, so the tough part is make sure that you have all the same units. That's one thing to kind of watch. Like 4 meters, 8 meters, 6 meters. We still have time left in class, right? About 15 minutes. Okay, let me just refresh what your schedule is going to look like. I'm going to stop this recording. I just want to refresh what your schedule looks like for the rest of the week. That's tomorrow.